Hello and welcome to the Hour 35 slideshow. Our objective today, students will find interior and exterior angles in regular and non-regular polygons. Please pause the video now and complete the do now. Thank you. Pause the video now. Okay, so continuing on, we all know that the sum of the interior angles of a triangle is 180, but what was the sum of the interior angles of your quadrilateral? Hopefully you said 360 degrees. Here's just a quick little example. We've got a quadrilateral and the four angles have been measured. If you go ahead and add those up, you'll see that the result is also 360 degrees. So, how about the sum of the interior angles of a pentagon? Well, here's a quick example of a pentagon and its angles, and you don't have to measure them and add them up. I will, and the result is 540 degrees. So far, is there a formula for finding the sum of the interior angles of any n-gon? As you can see, for 3 sides, it's 180. For 4 sides, 360. For 5 sides, 540. Go ahead and pause the video and see if you can work out a formula for finding the equation given n sides. Again, pause the video now and try to find that formula. Okay, so hopefully you've seen that this equation can be found by finding how much the increase is between each of the terms. This is 180 increase, 180 again, and so our equation is probably going to have a rate of 180 degrees. Now, in order to find the intercept, we need to go backwards 2, 1, 0, and if you go backwards, 0, negative 180, all the way to negative 360, you'll see that again this has a rate of 180 and an intercept of negative 360. Its equation is 180n minus 360. Now that's not the only way to write this answer, but that is one way. So 180n minus 360 is one way of finding the interior angles, the sum of the interior angles of an n-gon. Here's another way of looking at it. If you take a polygon, in this case a quadrilateral, and cut it along one diagonal, you'll see it has 2 triangles, 1, 2. If you take a pentagon and cut it from a point, multiple diagonals from that point, you'll see it has 1, 2, 3 triangles. So again, it's got 4 sides and it creates 2 triangles. If it's got 5 sides, it creates 3 triangles. Whenever you have n sides, it will create n minus 2 triangles. So any n-gon can be divided into n minus 2 triangles, and each of those triangles, the angle measurements sum up to 180. So the 3 angle measurements here, the 3 angle measurements here, the 3 angle measurements here, they all add up to 180 each. So in this case, we can just do 180 multiplied by 3. In this case, we could do 180 multiplied by 2. And if it's a polygon with n minus 2 triangles, we can just multiply 180 times n minus 2. So that's our new formula that gives us the same result. And it's a new conjecture for your notes. The sum of the measures of the n interior angles of an n-gon is 180 times n minus 2. And again, that's because there are n minus 2 triangles, and each triangle has 180 degrees in it. So just multiply 180 times n minus 2. Okay, moving on. Here it is one more time to review, just to be 100% clear. Triangle has 3 sides. It has 1 triangle inside. The sum of the measures is 180. If the polygon has 4 sides, there are 2 triangles. 2 times 180 is 360. 5 sides, 3 triangles, 3 times 180 is 540, and so on. 6 sides, 4 triangles, 4 times 180 is 720. Okay, so putting it all together, if a polygon has n sides, it has n minus 2 triangles, and then n minus 2 gets multiplied by 180 to be either 180 times n minus 2 or 180 n minus 360. They are the same thing. All right, so that's that. Those are our formulas for the sum of the interior angles of an n-gon. Okay. So, what about the sum of the exterior angles of a polygon? Let's investigate that. Here is a picture of a polygon, and it has 5 exterior angles. The exterior angles are those angles that are on the outside of the polygon, like so. Okay. So if we add those up, you'll see that the result is, in this case, 360 degrees. And it is always going to be 360 degrees, no matter what the number of sides is, and no matter what each of the angles is. A way that you can remember that and think about that is, if you can imagine that you're standing at a point along one of the sides of the triangle and you have to walk around this polygon. You walk forward and then you take a right. Then you walk forward and you take a right. Walk forward, take a right, walk forward, take a right, walk forward, and take a final right. And when you're done, you've turned completely around. And anytime you turn completely around, you've rotated 360 degrees. So no matter how many sides that polygon has, if you walk all the way around it, you will turn 360 degrees around. So our sum of those angles will always be 360 degrees. Okay, so that's a conjecture to add to our notes. For any polygon, the sum of the measures of their exterior angles is, you guessed it, 360 degrees. So go ahead and add that to your notes. Okay, so after you've added that to your notes, we're going to continue on. Here's just a quick little cool little animation I found. Here's a pentagon, and I've got the 5 angles measured at the top here. And yes, you know that their sum is, indeed, 360 degrees. I'm going to take this polygon and I'm going to make it very, very small. I'm simply going to squish it down so that all we can see left over are its exterior angles, like so. And surprise, a full 360 degrees. Let's see that again. There's the polygon, and when we shrink it down, there's the angles all together forming 360 degrees. Perfect little circle. Okay, so that's that. I could take this and make it into a quadrilateral. Just take one of the angles and get rid of it. So I've gotten rid of angle 5. And now angle 5 is 0 degrees, but the rest of them are a little bit bigger in some cases, and still their sum is 360 degrees. Let's do that again. This time I'll get rid of angle 4. I'm sorry, angle 2, I guess. And this time angle 2 is 0, angle 5 is 0, but still those 3 other angles add up to, you guessed it, 360. So, to review, for all n-gons, the sum of the interior angles, as we said before, is 180 times n minus 2, or 180 n minus 360. The sum of the exterior angles, as we just said, is always the same. It is always 360. So 2 main ideas there. Moving on, let's talk about what happens when the polygon is equiangular. Now in this case, all of my pictures are regular, and so obviously if it's regular, it's also equiangular. So to be specific, all of the angles in this equiangular polygon are the same. And it's important that they're all the same, because if we know their sum, we can find out what each one is by dividing. Let's do this. So as our first example, what if our polygon was a triangle? So an important number in all of our calculations is going to be 3. So the sum of the interior angles, as we saw before, is going to be 180. But each interior angle is going to be a simple quotient. We're going to just do 180 divided by 3, and each of these angles is 60. So 180 over 3 is 60. Now each exterior angle is going to be, well, I've drawn one of them out here, but to find it, there's 2 ways about it. If we already know that the interior angle is 60, we can simply find its supplement. We can simply do 180, take away our 60 is 120. So this house out here has to be 120 degrees. Another way of thinking about that is all three exterior angles have to be the same. Let me clear off a little space here and draw what I'm talking about. Okay, so a little bit cleared off. There we go. So if this exterior angle is the same as this exterior angle, which is the same as this exterior angle, and they're all equal to each other, but their sum has to be 360, then to find each one, we're just going to take 360 degrees and divide it by 3, and each one is therefore 120. So pretty basic process. You take 360, which is the sum of all of them, and divide by 3, which is how many of each there are. Let's do this again, ramping it up. If it's a quadrilateral, the sum of the interior angles, as we saw before, that's going to be 180 times n minus 2, and 180 times n minus 2 in this case is going to be 180 times 4 minus 2. Our grand sum is 360. Now, each interior angle is found by just dividing that total by 4, because there's 4 of them. So we've got 4 of them, so we're going to divide 360 divided by 4, and yes, that's good old 90. Each interior angle is 90 degrees. Now, the exterior angle is obviously also 90, because that's the supplement of 90. But the way I'd like you to think about it is like before, there's multiple exterior angles on this figure, and if we know that the sum of all of the exterior angles is 360, we just take 360, which is the exterior angle sum, and divide it by 4 to get our exterior angle is 90 for each exterior angle. Okay. I know that there's a lot of 90s going on here. There are 90 degrees on the interior angles, and there's a 90 degree on the exterior angle. Moving on to the next figure, we've got a pentagon, 5 sides, pentagon. Key number here is 5. So our interior angles, like before, we're going to do 180 times n minus 2 to get their sum. That's going to be 180 times 3. Grand sum is 540 degrees. So the sum of all of the interior angles is 540. To get each one, we're going to simply divide 540 by 5. So 540 divided by 5, 108. Each interior angle is 108. The exterior angle, let me write that on here. The exterior angle is simply the supplement of 108. That's right, 72. But the way I'd like you to think about it one more time is there are multiple exterior angles and they're all congruent. Each one is 72. So there's one more, there's another, there's the final one. Each of those exterior angles is the same. If there's a grand total of 360 degrees in those exterior angles and we divide by 5, we should get 72. Check it on the calculator if you don't believe me. So 72 degrees for each exterior angle. 360 divided by 5, 72. Okay, one last one, just to be 100% clear. We have a 6-sided figure. The interior angles is 6 minus 2 times 180, which is a grand sum of 720. We divide our 720 by 6, and each interior angle is 120. So 120 degrees for each interior angle. Again, the exterior angle is simply the supplement of 120, which is 60. But the way I absolutely positively need you to think about it is if there are 1, 2, 3, 4, 5, 6 exterior angles and they're all the same, then we can simply take the grand sum of 360 degrees divided by, you guessed it, 6, and that tells us that each exterior angle is 60 degrees. So 360 divided by 6, 60 degrees for each exterior angle. Okay. We've got a table here that we're going to fill in, and if you get the handout, which is on top of the overhead projector, you'll see this handout has already been filled in, but we're going to fill it in here. If I have three sides, there is one triangular region inside of it. Four sides, two. Five sides, three, etc. If there are n sides, n minus two triangular regions. Pretty basic. Let me clear that off. Now the sum of the interior angles is simply the previous number multiplied by 180. So I take 1 times 180, that's 180. 2 times 180 is 360, etc. 360, okay, 540. 4 times 180 is 720. Okay, and now to get this value, I'm simply going to take n minus 2 times 180. And so 180 times n minus 2. That is our sum of interior angles of an n-gon. We've mentioned that before. Let me clear that off. Okay. Almost there. Got it. Okay. So each interior angle, if it's equiangular, we're going to divide those angles up. We're going to divide 180 divided by 3, and that gives us 60. We're going to divide 360 by 4, that's 90. 540 divided by 5, 108. 720 divided by 6, 120. And then the fun formula that we've got going on down here now is to take that sum, which is 180 times n minus 2, and divide it by how many there are, divided by n. So that's our formula for each interior angle if it's equiangular. Moving on, let me clear this off. All right, that didn't work. Let's try that one more time. Just going to clear these numbers off. Awesome. Okay. Each exterior angle, if it's equiangular, is going to depend again on the fact that they all add up to 360. So if we have a sum of 360 and we divide that evenly by 3, we get a grand, or at each exterior angle is 120. If we take 360 and divide it evenly by 4, that is 90 each. 360 divided by 5 is 72 each. 360 divided by 6 is 60 each. And then finally, 360 divided by n is simply 360 over n. So that's the formula for each exterior angle if it's equiangular. Okay. Here's some practice problems to apply these concepts. Page 259, numbers 1 through 5. Please pause the video and do these problems now. Okay, so for number 1, here's your solutions, 900, 1080, etc. The quickest way to get that would be to go to your calculator and in y equals in the equation screen, simply type y equals 180 parenthesis x minus 2, and you can look in the table and see those values. For number 2, since they're asking for the measure of each of the angles, and it's equiangular, we're going to use the formula y equals 180 times x minus 2. Oops, I can't write my 2 there. Let me start that over again. We're going to write our formula y equals 180 times x minus 2 all divided by x. If you put that in y equals and look in the table, you'll see those are the values you should get. You'll notice that they use fraction form for a couple of them, so the decimal or the fraction, either one is fine. Okay. Now, you might have noticed that they didn't say the word interior angles here in number 1. They just said that some of the measures of the angles. It's implied that they were referring to the interior angles. Same thing here. That's implied that that's an interior angle. Number 3, this angle here is 90 degrees, and when you add the 3 angles that we have now and subtract from our sum of 360, you get the resulting angle of 122 degrees. For the next one, we find the adjacent angles next to those exterior angles, Next to 70 is 110. Next to 68, I believe we're going to say is 112. Now, the sum of these four angles is going to be subtracted from the sum, which we should expect, of 720, because it's a hexagon. And so 720, take away those four angles, will give us some value, which we'll then have to cut in half. And when we cut in half, we should get 136. So B is 136, and so is this angle that's congruent to it. Finally, number 5, this is a regular pentagon, or an equiangular pentagon at least. And so we should know by using our table or using our formula, this is going to be 180 times n minus 2 all divided by n, where in this case n is 5. So that'll be 180 times 5 minus 2 all over 5. That's 180 times 3 all over 5. That's 540 all over 5. That's 108 degrees. So E is 108 degrees. So are all these other angles. So this one's 108, this one's 108, and adjacent to each 108 is 72. And so we now have a triangle with two 72-degree angles and a missing angle, and that angle is indeed 36 degrees. You might recognize that triangle. We've seen it before. A pair of 72s and a 36. That's an isosceles triangle that some people call a golden isosceles triangle. Hey, let's color it in gold. Okay, moving on. Here's some practice problems to try on page 264. Please pause this video now and try these problems. Okay, number 3. How many sides does a regular polygon have if each exterior angle is 24 degrees? So we know that the exterior angle is 24 degrees. That's important. We know, therefore, that we can use the formula 360 over n. And 360 over the number of sides will give us the exterior angle of 24 degrees. There's a variety of ways to solve that problem. You could multiply both sides by n first. That'll give you this. And then you could divide both sides by 24, and that'll give you 360 divided by 24. So 360 divided by 24 in this case is 15. This is a 15-gon. Okay, number 4. Let me clear this off here real quick. Number 4, how many sides does a polygon have if the sum of the interior angles is 7,380? So let me clear this off real quick. We should be using the formula 180 times n minus 2, because that's the sum, and that's going to be equal to 7,380. So let me get my calculator real quick here. First step, we're going to divide both sides by 180. So 7,380 divided by 180 is a magical 41. So dividing by 180, we're left with n take away 2 is 41. And now common sense, add 2, n is 43. So this is a 43-gon. That's how many sides that one has. Oops, I just covered the answer. There we go, 43-gon. All right. Number 5, we're trying to find that exterior angle there. There's a lot of ways to do this problem, and it makes sense to find the exterior angles and then subtract the ones that we know from 360 to get our missing exterior angle. We have a 40 degrees right here. And so then we add up our 40, our 60, our 84, and our 68 to get a grand sum of 252 for now. But 360 should be our sum, so 360 minus 252 is 108 degrees. So our exterior angle that's missing is 108 degrees. Finally, number 6, we should have these exterior angles and a missing one here. We've got a missing angle of 180, take away 68 is 112. So we've got some exterior angles that we know. and they should all add up to 360. So we're going to subtract those angles from 360. We're going to take 360, take away 112, and 43, and 69. That gives us a remainder of 136. Whoops. 136 is our sum of those three remaining angles. And so 3 into 136, our angle is supposed to be 45 1/3. Simple 45 1/3 is our result. Okay, last one, number 7. This beautiful little polygon in the middle here has 1, 2, 3, 4, 5, 6, 7 sides. And so to find each interior angle, we're going to go 180 times 7 minus 2, all divided by 7. And that gives us a fun little number of 128.57-ish. Obviously, there's more decimals after that. So this angle right here is 128.57. So is this 128.57. So is this 128.57, etc. So it's clear that we're going to need to subtract that from 180 to get C. And the supplement of that is going to be a nice 51.428, 51.42857, etc. That's going to be 51 3/7. Okay, now this little spot right here, let me do that one more time. This spot here, those three angles all add up to 360. So we're going to take 360 degrees minus 128.57-ish. And that'll be 360 take away 128.57 leaves 231.428. And that's the sum of these two angles. We're going to cut that result in half to get D, and that's approximately 115.714, and that's 115 5/7 in case you wanted to see it as a fraction. Okay, so that's that. So you are expected to know the formulae for this whole bottom row here. If you haven't already filled it out, now would be a good time to do so. For any n-gon, there are n minus 2 triangular regions. There is 180 times n minus 2 degrees in the sum of all of those angles, in that interior angles. If you want to know what each angle is, if it's equiangular, you'll take 180 times n minus 2 and divide that by n. Working backwards, we know that the sum of the exterior angles is 360 always, and if it's equiangular, then each exterior angle is simply 360 divided by n if there are n sides. So those are the formulae you're expected to know. Please commit them to memory, and that's that. Here's your homework. Be careful with it. Please make sure that you take your time. And that's it. Have a good one. See you next week.